Hello, and welcome to my video for binary trees and how to check to see if they're balanced. Balanced trees is a classic problem used in interview questions. So in this video, we're going to briefly discuss what a balanced tree is, what its characteristics are, and then we will write up some code that will check a tree for balance. What makes a tree balanced? This is a tree whose difference between the left subtree and the right subtree. So the left subtree and then the right subtree height is at most 1. All complete and full trees are balanced. I think it's important to point out the difference between height and depth. So if we look at this tree in this example, we can get a better look. Talking about depth, depth is calculated by traversing from the root node here, root node 1, to the leaf node, or then this null node here, node 6. So height is calculated inversely. So it's by traversing the leaf node to the parent node. So let's check to see if this tree here is balanced. We're going to take this left subtree here, this whole left subtree here, and we're going to take this right subtree here. What we're going to do is we're going to calculate the height of the subtree on the left with the height of the subtree on the right. We're going to subtract those differences, and then we're going to find out whether or not this tree is balanced or not. So if we look at the height on the left, we could say 1, 2, 3, 4. So it has a height of 4. Now the one on the right will have a height of 1 and 2. So we subtract the difference, 4 minus 2, we get 2. And this is not a balanced tree because the difference between the left subtree's and the right subtree's height is more than 1. And therefore, it is unbalanced. So with tree data structure problems, you should always consider recursion. This is because trees have a hierarchical structure. It's not like an array or a list, which has a linear structure. Just ask yourself if the problem you're trying to solve can be found using the solutions of the same problem you use for the smaller subtrees. For this problem, when I consider recursion for deciding if a tree is balanced or not, I think of finding the height of the left node, which is a subtree, and then finding the height of the right node, the other subtree. And then all I have to do is find the difference between the two. So let's see how we want this to work within a node class. So after defining the init function, we want a function that will find the height of the tree. And don't forget, we can make this recursive because we are going to be using all of these subtrees. So let's define this function, height helper. This is going to be our helper function. Now I want you to keep in mind that we are defining this function in a class. So there'll probably be other functions within this class in order to actually run this code. That's why I'm just typing it up here on Google Docs for you, just so we can talk about the actual code, because this actual code is really the meat of the whole problem. So now, because we are using recursion, we need to have a base case. So let's write if root is none, we're going to return 0. Now this is just saying that if I'm at a root with no children, or if I'm at a leaf or a null node on the tree, then our height is going to return to 0. If it is not 0, we need to return the height. So we will type in a return statement here with a 1 plus. Don't forget that 1 plus, because we're going to start on 1 here for the node, the parent node. 1 plus the maximum height of the left and right subtree. So here comes the recursion. We need a return statement for 1 plus the maximum. Now here's the recursion, height helper for the root dot left node. We're going to do that between helper root dot right. All right, so we're going to use that recursively to find those heights using the subtrees, and that's it for our first function. That's it. We're only trying to find the heights of the left subtree and the right subtree. So now we need a function that will return a Boolean. So let's define this as balanced. So, and again, our parameter will be root. All right, and because we're going to be using recursion within this function, we also need a base case. So if the root is null or none, then we will return 0. This is saying that an empty tree without any nodes is a balanced tree. Next, we are going to need a return statement, a Boolean, indicating true if the tree is balanced, and then false if the tree is unbalanced. We write first the balance function for the right node. It is a Boolean, so we can use the word AND when we combine our statements. Turn balance function for the right node, and balance function for the left node. And we will take the absolute value, height helper, for the left node, subtracted by height helper for the left node. And remember our criteria for a balanced tree. It cannot be more than 1. So we're going to say less than or equal to 1. So all of this is saying that if the subtree on the left is balanced and the subtree on the right is balanced, then we subtract the heights on both sides, left and right subtrees, to ensure that the difference in height is 1 or 0. And now this is a simple solution for this question and doesn't really account for efficiency. And there are ways to adjust for time complexity. However, this is a simple solution and it works, but it will give you sort of a template to build upon if you would like to sort of create a more efficient sort of script. All right, and that's it for this video. Thank you.